Hello everyone. In the previous video we have discussed theory part of Quicksort. Now in this video we are going to apply the same logic in C programming language. Before starting this program, I request you just focus on those line of codes which I am going to highlight. All the code will be clear, right? See, first thing. So this is integer array 50. I am going to take the array which will take 50 elements, and this is the variables. This is the basic code actually. How many elements you want to store in array? I am going to take, for example, 10 elements among these 50 elements. As you know, we are going to restrict it in this program. This is static memory allocation. Array is the static memory allocation. We are not doing any dynamically. We are not going to do any dynamic. Malloc, I am not going to use. You can use also. See, simple. So, among the 50 elements, I am going to take 10 elements with this n array, n variable. Enter the array elements. Simple. Those 10 elements will be entered and scanned and allocated in memory, right? And those elements will be printed before sorting. Simple. This line is very important. 15, 16, 17 only for printing, and 20 and line number 12, 13, 14 is for scanning. Once again, line number 20, this line is for the scanning of the elements, and line number 15, 16, 17 for printing the element before the sorting. Now, and line number 10, 11 for how many elements you are going to store in array among 50 elements. Is it clear? Now, line number 18 is going to call the function Quicksort, and now in Quicksort we are going to pass the array name, first index of the array, that is 0, and last index of the array, that is n-1, right? Okay, and line number 19 is going to say array after the sorting in ascending order, and this is the loop for printing all the elements of the array, right? Now come to this line number 18. This is the function calling function. Now this function will call, and the control goes to line number 25, right? In line number 25 says Quicksort. We are going to use. Now you remember in previous video, in theory part of the Quicksort, we have written this code. Simple, right? So this is the Quicksort array name. We have passed array name, a start element as a p, and the end index as a r. Remember, right? P is less than r, that is start is less than end. We have applied the partition algorithm, and we find the proper position of the pivot element and stored in the position variable. And now we have what? We have called the function call array name start and what? Position -1. So let me write something here. Suppose this is the array list. I have selected the pivot element P, and after applying the this partition algorithm, I found the position. This is position, and in position we have called the first recursive call as what? Array name, and what is start index? This is I, this is start, and this is end. This is start, and this is what? Position -1. That's very easy. Position -1. And next recursive call array, and what is this? This is position. This is position +1, and that is end index. This is end index, and this is position +1. This is array. We have already discussed in theory part. Please watch if you not visited that video, right? Okay, this is the Quicksort, right? Okay. Now come to the partition algorithm. Now, okay, before moving forward to partition algorithm, let me execute this code and let's see how the output will be. So it is asking how many element you want to, this line number 10, how many element you want to store. Suppose I am going to enter 5 elements and enter, right? Now line number, where is the line number? Line number 12 is going to ask enter the array element, Now control is going to take the loop for n times, 5 times. I am going to enter the elements. Suppose I am going to take 4, 2, 1, 8, 6, any number. So this is a random 5 number I have entered. Now, so what should be the output? Array before sorting is, now let's see the output. See, array before the sorting is what? 4 to 186. Array before the sorting 4 to 186, and after the sorting 1 to 468. This is the sorted order and this is unsorted order element, right? So this is the output. Now come to the partition algorithm. See, so I think this part is clear to you. Main function and quicksort function, right? Now come to the partition algorithm. Now listen carefully. In partition algorithm, before going to discussion on partition algorithm, let me tell you one thing. See, there is no proper algorithm for partition algorithm. Remember, listen carefully. There is no proper algorithm for partition algorithm. But one thing is important. Partition algorithm must take order of n time. Okay, otherwise your quicksort will take more than n log n time in average case and best case. So just you can create your own partition algorithm in such a way that will take order of n time. Now in this program, listen, in this program I have taken the 3 partition algorithm, and now I am going to execute all the partition function one by one, and that will show the output the same output will be shown, right? The first thing is partition. I am going to execute this partition. Now I am going to take first partition which we have discussed in theory part. Okay, now I am going to take the comment. See, ये comment and non-executable code. Now I am going to uncomment this part. See, right, this is the part. Okay, right. See, so in the theory part we have discussed this partition algorithm. Simple partition algorithm is this one. While pivot position is equal to false, this simple, we are moving the compare from right to left first, okay, and next part I am comparing the left to right. And for while, loop till pivot is positioned at proper place in the sub list, right? We are going to execute this while loop till proper position will be at for the pivot element, right? Okay, see, so this is the code for what? Pivot partition algorithm which we have discussed in theory part, right? Simple, that's very easy. Okay, and now we have used this exchange function, right? So where the exchange function? This is the exchange function. This is the exchange function. This is simple exchange function. A temp is equal to A is B, B is equal to C. Now the question is, why I am going to take the call by reference? See, listen, this is the call by reference, and this will reflect the original array elements. That's why taking this call by reference. Otherwise, if you take the int A, int B, and temp is assigned A assigned B, B assigned A, temp assigned B, then in the original array the exchange of the element will not reflected. So that's why we are using the call by reference. Now simple, this is the first partition algorithm. Let me execute this one, and after that I will take the another partition, compile and run. Now how many elements you want to store? I am going to take 6 elements, any, and random 5, 2, 1, 8, 4, 3, right? So these are the 5 elements. Now see the output. Before sorting 5, 2, 1, 8, 4, 3, and after sorting the elements are 1, 2, 3, 4, 5, 8. Simple, right? Okay. So this is the one of the partition algorithm, right? Simple. Now come to the another partition algorithm. Now I am going to comment this one. This is one of the also a partition algorithm. See, now let me execute this one. I am going to take element 7 and random element 1, 3, 2, 5, 7, 8, 9, 3, right? Okay. So these are the array elements before sorting 3, 1, 2, 5, 7, 9, 3, and this after sorting 1, 2, 3, 3. There are 2, 3 now. Yes, 2, 3, 1, 2, 3, 3, 5, 7, 9. Simple. So this again, this partition algorithm is going to work. Again, I am going to comment this one. And now open this another partition algorithm. So what I want to say, simple, partition algorithm may be different, but compulsory is it will take order of n time. See, this is another algorithm, a partition algorithm, another strategy to find the, actually what is the motive of this partition algorithm? Simple, find the proper position of pivot element. Simple, nothing else. You can use your own partition algorithm, right? You can use your own logic to find how we can split the array in two ways such that all the lesser element of the pivot element is left side and all the larger element is the right hand side. You can use your own logic partition algorithm, but condition is order of n time should be. There should be one loop. Actually, in this case, one loop is there. That's why order of n time. Compulsory, this is order of n time must be taken by the algorithm if you design your own partition algorithm, right? So this is another partition algorithm, right? Implementation. Let me execute this one also. This is 5. You can take any elements 5, 3, 1, 2, 9, right? So this is the elements before sorting 5, 4, 2, 1, 9, and after sorting 1, 2, 4, 5, 9, right? So this is the sorting implementation in C. Now, so we have seen all these three partitions individually, and exchange you know already due to the we are using the call by reference because of reflection on original array list. Okay, and what is the remaining part? This is done. This code partition done. This partition done. This partition done. Exchange done. Now come to the above. Now you know already all these function must be declared. Take care. This quicksort is declared. Partition algorithm function is declared. We are going to promise with compiler. I will create a quicksort algorithm, quicksort function, which will return the void return that will return the void data type, and that function will take 3 arguments as an integer array. Another argument is integer and another argument is integer. Similarly, I will use the partition algorithm, partition function that will take 3 arguments, integer array, another one is integer, another one is integer, and this function will return integer value. How you can say integer value? The particular position of pivot element, that is the integer value, that will be the integer value of the array list. So that's why we are using the integer return type as integer. And what is the void exchange? I will use the function in my program. I will make an exchange function. It will take the 2 arguments, which is type of integer pointer and integer pointer, and will return the void data type, right? So this is simple. And what is this? This is the enum boolean. We have used the true false for this function, right? This one for the boolean true and false. I just like a marker, like, right? So I will share this code in class notes, right? So just follow this one. If any doubt, please write in comment box, and you can follow the notes also, right? Okay. So thank you for watching.